going to get started. So before we start, I haven't been around a lot lately, but I wanted to share just a little anecdote that happened this morning. As I was coming to school, I was mistaken for Mevin Hooten. I was really flattered by that because I thought, in my old age, I'm becoming more intelligent and better looking. And then I realized it was probably the hat, or more likely my new haircut. So, flattery, I guess. Well, this is really a bittersweet moment for me because Rake is my last graduate student to defend. And I think I speak for all of us, is that one of our greatest joys we have as faculty members is working with our graduate students, and our undergraduates too. Our graduate students we have a longer relationship with, sometimes prolonged, longer than we want, but it's always been rewarding and enjoyable, and I'm definitely going to miss that. So our Tiger Research Program started 10 years ago. And Rake has been engaged in the project almost since its inception. And many of you know Pranav Chanchani, who finished his PhD a few years ago and now heads the WWF program in Asia for tiger conservation and management. So the initial research of Pranav's focused primarily on protected areas.
What's happening?
And one of the things that was observed, initially anecdotal, but evidence began to accumulate, is that the tigers in North India were not restricted to protected areas. And in fact, as this picture illustrates, in what looks like a growing sugarcane field, is they're often in the matrix that surrounds these protected areas. And these matrices are heavily dominated by agriculture and people and villages. And this then greatly increases the potential for human-wildlife conflict. So it was a logical extension of Pranav's work for Rake to focus largely outside the boundaries of the protected areas on the agricultural matrix and looking at the use of this matrix by tiger prey, but equally important, the potential for human-wildlife conflicts, and to get a better understanding of how to mitigate those conflicts and the degree of human tolerance. Now, I want to say a little bit about Rake and not embarrass her. So, Rake is extremely capable and hardworking. And she's not intimidated by even the most sort of advanced, cutting-edge methods in ecology, which I think I speak for everyone in here, definitely myself, we struggle to stay current with. And we're constantly reaching the limits of our understanding. But I think, more importantly, and this seems to be common of graduate students in our program, is she's confident in her abilities, but not arrogant. She recognizes the limits of her understanding, but it's not intimidated by taking on even the most difficult challenges. And so I'm proud to have Rake as my graduate student, and I'm sorry that she's my last one, but who knows? I'm hoping to hang around a bit longer, and maybe I'll have some new opportunities. Now, one of the things I want to do, and hopefully not embarrass her, is that we have had, in addition to Pranav and Rake and myself a bit, an unofficial member of our Tiger research team ever since its inception, and that's Dr. Larissa Bailey. She has been deeply engaged. Hey, there's Mevin. Mevin, you missed my Mevin joke. We'll have to
do it again.
and has contributed really significantly to our work.
So that we look
I was mistaken, but now I know why. So you can see the resemblance there. But he's much better looking than I am, especially now. Okay, so, and I don't mean to embarrass you, but I want to say that I just got an update on our India Exchange grant from Val Romero yesterday, and we still have money for people to go to India. And I know I'm speaking for both Pranav and Rekha. We would love to have you see tigers in the real world, in the wild, and not have them just be lips on computer screens. So we'll talk later. We have a ticket ready for you. Okay, so enough of hearing me. Rekha, you have the stage.
Okay. Okay, thanks Barry for that introduction, and thank you all for being here. I'm really excited to talk about my doctoral research work, which was focused on understanding the spatial ecology of tigers and their prey species in these farmland habitats. And as we know, this is to inform land sharing-based conservation initiatives for species such as tigers and other large carnivores as they increasingly find themselves in the midst of dense human populations. So before I talk about my specific work, I wanted to give you a broad overview of why this is even a relevant issue. Now, land sparing has been sort of the broad paradigm under which we have endeavored to conserve biodiversity. And this means setting aside large, largely pristine habitats for the conservation of species. And our global protected area network stands testimony to that fact. Now, this paradigm is predicated on the idea that human-modified and human-dominated lands have little or no conservation value. We basically endeavor to protect that which is either untouched or unsullied by humans. Now, ongoing declines in biodiversity on account of land use change and climate change have prompted calls for expanding this global protected area network. And we all know of prominent calls such as Nature Needs Half or the Half Earth Initiative. But the question is, where will this protected area expansion occur? Now, in many parts of the world, especially where there are dense human populations, protected area expansion is complicated by the additional competing pressures on land placed by human populations. But it is in these parts of the world that there is a need to expand conservation initiatives. There is a need to find additional habitats to protect some of the species that take up residence there. So let me illustrate that point here. This is a map of global human modification. The blue areas indicate areas of intense modification, such as due to urbanization or agriculture, and the brown areas are areas that are relatively pristine. I'm going to plot on this the ranges of some of the most charismatic and flagship species of conservation and explain to you why we need to look beyond protected areas if we want to conserve these species. So here is part of the range of tigers in South Asia and extending into Southeast Asia, shown here in red. This is the range of African lions and the last remaining Asiatic lion population right there in India. The ranges of Asian and African elephants, the ranges of brown bears. If you look at these species, they're all wide-ranging, all threatened to varying degrees, and they all overlap human-dominated lands. Within these landscapes, protected areas are small, they're inadequate for their conservation, and their expansion is increasingly difficult because they're hemmed in by human populations. So it is increasingly being recognized that the long-term persistence of these species depends upon looking beyond protected areas and reimagining the conservation value of human-dominated lands. Now, nowhere is this more true than the case of tigers in India. 70% of the global tiger population occurs in India. The global tiger population, by the way, is at about 3,200 individuals. So we are talking about 22 or 2,300 individuals in India. Now, protected areas in India cover about 5% of India's terrestrial surface. And undoubtedly, these protected areas have been instrumental in tiger populations persisting into the 21st century. They serve important functions like protecting critical habitats, including providing protection for tiger prey. And in many instances, they provide protection to populations from illegal harvest. As we all know, poaching is one of the most significant threats facing tiger populations in the wild today. But it is also important to remember that 35% of India's tiger population occurs outside of protected areas in India. More importantly, most of these PAs are small. So to illustrate that, the median size of protected areas in India is about 300 square kilometers, whereas the median size of a male adult tiger's home range is about 160 square kilometers. So any initiatives that involve either increasing tiger populations or doubling tiger populations is now constrained by just the size of these protected areas in India. And we all know the relationship between persistence probabilities and population size of a species. They're sort of negatively related. Moreover, the context within which these protected areas occur is also important. So here's an example of a sort of a typical tiger landscape. Now, the areas in gray indicate parks or protected reserves for tigers, and I would like you to ignore the numbers there. And these are typically embedded within a matrix of degraded forests, shown here in green, and largely agriculture, which is all of these yellow areas. Studies on genetics on these populations interestingly suggest that despite the isolation of these parks from each other, most of the populations in these landscapes are genetically undifferentiated, implying that tigers are moving through this sort of protected matrix, and that there is still functional connectivity between most of these populations. But what are the threats that tigers face when they are in this unprotected matrix that remain unanswered or unaccounted for because of our myopic focus on protected areas? Human-caused mortality of tigers and their prey is a big issue in these matrix habitats. So that picture is of a tigress who we had previously recorded in a protected area in my study landscape. She was found dead in a village in 2016 while I was conducting my field work. This is a picture of a tiger that I received yesterday. This was a tiger it's a young male that was found dead. It was caught in a snare intended for potentially crop raiding herbivores. This was found sort of south of my study area. So these deaths are fairly common, and so is the death of tiger prey in the matrix, because these prey are also widespread in these unprotected habitats. Now, like I said, the populations of tigers and their prey within PAs are small. All of these deaths are an additive source of mortality that can have demographic consequences for populations within PAs. On the other hand, these species have tremendous impacts on the communities with which they end up overlapping spatially. So attacks on humans and their livestock are on the rise in many landscapes across India. And a more pervasive problem is the depredation of crops on account of tiger prey, such as seen here. What these sorts of threats do is, one, they decrease the tolerance of communities for co-occurring or sharing landscapes with these species. And more importantly, they introduce an ethical challenge in arguing for the conservation of these species. So there is a need to expand our conservation efforts beyond the boundaries of protected areas and comprehensively bring in human-dominated and human-modified landscapes within the conservation purview. And this sort of approach is largely called land-sharing-based conservation. Now, some of the measures that might be employed beyond protected areas would be proactively issuing land use policy measures and also putting in place conflict prevention measures. Now, both of these require an understanding of the spatial ecology of tigers and their prey. The tiger is a very well-studied organism. There's a joke that in India there are more tiger biologists than there are tigers. But this study here, which summarized the locations over which studies on large carnivores have been conducted in India shows that most studies on tigers have been conducted within protected areas, that is, landscapes that are completely free of human disturbance. So the x-axis here basically shows the number of studies, and the x-axis shows the species, and the y-axis shows the number of studies conducted in different, like, PAs and non-PAs. You can see its majority sort of skewed towards studies within protected areas. So to address some of these knowledge gaps, we conducted a study in the central Tarai landscape. This landscape lies right along the Nepal border, right up there in northern India. And it's comprised of a series of protected areas seen here in deep red, and multiple use forests seen here in sort of dark pink. And as you can see, these parks are small, they're isolated from each other, and embedded within a matrix of dense human populations. Now, this is perhaps the most densely populated part of the tiger's extant range. This is probably the most densely populated part of the tiger's extant range. And to give you a sense of what that means, the landscape which this landscape occurs within a state that has about the same population as Brazil. So this is, or 15% of India's population. So this is a really densely populated part of the world. So this is a landscape that is of critical importance to tiger conservation because it harbors a metapopulation of about 150 tigers within these protected areas. Now, a study conducted by former FWCB graduate Pranav Chanchani demonstrated that tiger densities are largely skewed and occur close to the boundaries of these protected areas. So here shown in green are the protected patches, and the red areas indicate tiger activity centers. So you can see that they're all along the boundaries of these parks, and it's reasonable to expect that many of these home ranges of these tigers potentially extend beyond those parks and extend into the matrix. And tiger densities sort of mirror prey densities. Prey is an important predictor of tiger presence. So in this case, the density distributions of prey are also sort of concentrated close to the boundaries of these parks. So this leads us to expect that the matrix of the central Tarai landscape is rich not only in tigers but also their prey species. And we were interested in knowing what is the implication of the presence of these animals there. What is the conservation value of the matrix in sustaining tiger populations within this landscape into the future? And our specific goal was to understand the spatial ecology of tigers and their prey within these matrix areas, with the explicit intention of informing land use planning measures and human-wildlife conflict prevention measures. So some of our objectives were, one, to estimate the environmental drivers of tiger and prey habitat use in the region. Given this habitat use, what are the interactions with human communities like? What is the scale and nature of these interactions, and how do they relate to the probabilities with which areas are used by these species? And because we encountered some challenges in adequately addressing this problem, we were interested in developing this approach to jointly model how we can sort of bring together species space use probabilities and the probabilities with which they interact with human communities. So I'll go through these one by one. So we conducted this study in a 1,200 square kilometer sort of agricultural swath that separates two protected areas. So it is, in a sense, a corridor region here. The study area is sort of bounded by this orange polygon. The pink areas, the pink polygons, essentially outline settlements, settlement boundaries. And most of the people here belong to agrarian communities. They practice a subsistence style of agriculture and are dependent on forest resources to varying degrees. The Sharada River that originates in the Nepal Himalayas flows through the center of the study area. The river's dynamics makes available riparian habitats within the matrix and also supports some of the richest sugarcane agriculture in the world. Now, sugarcane is the dominant crop cover in the study area. And so the cover that's made available by these two vegetative features is essentially dynamic, that it doesn't stay constant across the year. So here you can see that sugarcane crop, when it's at its tallest, when it's ripe and it's at its tallest in the winter season, it's tall enough to hide this antelope species called the nilgai, that's about yay tall. But in the summer, when the crop is harvested, these are pictures from the same location. When the crop is harvested, there's significant increase in visibility in the landscape. The cover is mostly gone. And in the monsoon season, the crop grows back again, but significant portions of the landscape experience sporadic flooding. So there is a change in the way habitats are available across the study area. This complex of sugarcane and riparian habitats make it possible for multiple prey species such as wild boar, hog deer, and nilgai to use these areas as well. And for species that are using the study area, the risks largely arise from anthropogenic settlements. So settlements such as these, which are dense because there's a lot of people living here, and associated infrastructure such as roads, canals, etc. So our first objective was to estimate the environmental drivers of tiger and prey habitat use, and we used an occupancy modeling approach to address this. So occupancy modeling allows us to ask questions such as, what is the probability a discrete spatial unit will be used by the species of interest, and how do some of these factors influence that probability of use? And because we were also interested in the temporal aspect of a site being used, we looked at what is the probability that a used site will cease to be used in the subsequent season, what factors determine this, and conversely, what is the probability that an unused site will transition into being used in another season, and what factors influence that probability. Now, to estimate these parameters, we started off by setting up a sampling frame comprising of about 1.6 square kilometer grid cells. We excluded all cells that overlapped protected areas and randomly selected 94 grid cells using a spatially balanced sampling approach. Now, to estimate use probabilities, you need to detect the species, and tigers are very hard to detect even when they are within their native habitats, and we expected them to be even harder to detect within these human-dominated landscapes where they might exhibit elusive behaviors. So we used a couple of different survey techniques to generate detections on these species, starting with farmer interviews. So these were rapid surveys where we would walk through each of these grid cells along a random path, encounter farmers as they were working their lands, and show them pictures of the species that we were interested in generating detections for. And we would describe to them what these species look like and what their tracks look like, and we asked them if they had seen these species within the last month. While this is a rapid and cost-effective way to generate detections, it suffers from two kinds of biases. One, a farmer may have failed to see a tiger that was using his land, or any other species for that matter. And on the contrary, a farmer may report seeing an animal that was truly not using this site. And this could be because of a number of reasons, and I'll explain it here. So this is a case where, during our pilot surveys, we encountered this farmer who claimed to have seen a tiger track. He led us to this track, and it was indeed the track of a tiger. So there's an associated probability of a farmer truly reporting a tiger in a certain site. On the contrary, here is a farmer who detected a leopard track, thought it was a tiger, and reported it to us as a tiger track. So that is the probability of falsely assigning a cell as occupied or used by a tiger on account of these misidentifications. A false positive detection could also arise because the farmers don't understand the spatial or the temporal unit that we are interested in assigning detections to. But we took measures to minimize those errors, but those misidentification errors are harder to correct. So to account for these two sorts of survey errors or biases, we conducted additional sign surveys within a subset of those cells where we conducted interviews with farmers. So sign surveys involved walking a random path, an independent random path within some of these cells and looking for tiger signs or tracks, or even tracks of other species. So here is Barry when he visited me in field, having detected successfully a tiger track here, moving on to detect more.
I thought this was your example of an incompetent observer.
Now, sign surveys are a reliable way to generate detections for a number of species, but they don't do very well for species such as deer, because their signs can be easily confused with those of multiple other domestic herbivores in the landscape. So to clarify those errors, I meant to say there's an associated detection probability for the sign surveys. So to clarify the errors that may be involved in detecting herbivores, we conducted camera trapping surveys in a subset of the cells where we conducted both the farmer surveys and the sign surveys. So this involved placing a single motion activated camera trap within farmland areas, and they remained active for 30 to 40 trap nights. So just to repeat here, the orange cells are where we conducted just farmer surveys. The sign surveys were conducted in addition to the farmer surveys in the green cells, and the blue areas are where we conducted all three survey methods. So there's a detection probability associated with the camera traps too, that is the probability of detecting a species of interest on any given survey occasion. So we repeated these surveys in the winter, summer, and monsoon seasons. Survey effort was lower in the monsoon season because of flooding in the study area. Now we applied dynamic occupancy models that correct for both false positive and false negative errors to these data, and used a stepwise model building approach to build our model set, and used AIC based model selection to select from competing models. So the results I'll present here are based on the best supported model. So as expected, the true detection probability was highest for the farmer surveys and lowest for the camera surveys. So this justifies the use of farmer surveys as a way to generate detections for these species across a large landscape. However, there is a need to account for the false positive errors that are inherent to the survey method. Next, we found that the total length of drainages within a cell and NDVI, which is a surrogate for cover, influence the probabilities with which tigers use a cell. So the y-axis is the probability of use in the winter season. Now to show you what that looks like on the landscape, here is a cell that we surveyed. The arrow points to drainages. These drainages typically connect areas of native habitats within the landscape, and we expected these areas to be used frequently either as movement routes or because they provide additional cover within this area. Also, the NDVI signature was for a cell such as this that's comprised of both sugarcane cultivation and also has native riparian grassland habitats. Use declined with increasing distance to protected areas and with an increase in the proportion of the cell under human settlements. But it's useful to note that this use remains high up to 6 kilometers beyond the boundaries of protected areas. So there's at least a 50% probability of cells being used even as far as 6 kilometers from a park boundary. However, this use declines rapidly when the proportion of the cell that's under human settlements increases beyond about 7%. So this sort of suggests that these populations may be vulnerable even to minor increases in urbanization within this large landscape. The extinction probability, that is the probability that a cell that is used would cease to be used, increased with increasing distance to PAs and with the availability of permanent water sources. So tigers use continuously use areas that are close to protected area boundaries across the 3 seasons. And this relationship with water may have to do with the fact that in the summer season, all of these areas are used extensively for the cultivation of gourds and watermelon, which may add an additional source of disturbance. Whereas in the monsoon season, these are the areas that are most likely to be flooded right away within the first rainfall. So we used our parameter estimates to estimate what the probability of use was across all our sample cells. And you can see that much of the study area outside protected parks experiences a high degree of use in the winter, and this declines as we go through the summer and monsoon season, with use largely being restricted to areas close to the park boundaries. Now, this may have to do with just overall decline in the dispersal related activities across the 3 seasons. That is, maybe dispersal is really high in the winter season, or it may have to do with the home ranges of individuals that occur along park boundaries shrinking and expanding in relation to the availability of resources across these 3 seasons. So in summary, the spatiotemporal use patterns of tigers within this habitat or within the study area may be largely driven by the avoidance of humans rather than the pursuit of resources. We also detected 8 individual tigers using camera traps, and 6 of these had been previously recorded from within protected areas. We also believe that these areas are not just dispersal routes, they may also serve as breeding habitats, because during our surveys we detected a female with her cub. This is about maybe a little over a year-old cub, persistently using many parts of our study area during the winter season. And anecdotally too, we have recorded instances of females giving birth to cubs within sugarcane farmlands. Now, we conducted this exact same analysis for the prey species in the matrix for which we had adequate data. So this is the hog deer, which is an endemic endangered herbivore, wild boar, who we all know, much reviled agricultural pest. The nilgai is again an endemic antelope species that is not of conservation concern and is also considered an agricultural pest. We find that unlike tigers, all 3 species use sugarcane farmlands consistently across the 3 seasons. So this is a plot showing the occupancy probability, mean occupancy probability for each species across the 3 different survey seasons. So winter, summer, and monsoon. So their probability of use doesn't change drastically across these 3 seasons. We found that the probabilities with which wild boar use these areas were not explained by any of the covariates that we considered. However, cover, distance to protected areas, the proportion of settlements within a cell, the availability of native habitats were all drivers of hog deer and nilgai occupancy probabilities. Now, given that these species are so widespread in the matrix, we were interested in understanding what is the nature of their interactions with human communities? Like, how are they, what is the scale and nature of their interactions, and how do they relate to these estimated probabilities of tiger and prey space use? Now, I'll first talk about tigers and then move on to the prey. So here is a map showing incidences of attacks on humans by tigers. This is data collected by WWF between 2003 and 2016. So the pink areas, or the pink dots, basically indicate instances where a person was killed by a tiger, and the blue dots indicate instances where a person was injured by tigers. Now, traditionally, what we understand about the presence of tigers outside parks stems largely from data such as this. This map essentially shows where tigers potentially occurred during this period. Now, what happens in the absence of any other information, the map suggests that any instance where a tiger occurs outside the boundaries of a protected area is implicitly linked to a conflict event. That is, we are unable to think about the presence of tigers beyond these parks without conflicts occurring simultaneously. But when we look at this in the context of our estimated probabilities of use, and assuming that these use probabilities remain, have held for the period of time during which these data were collected, what we may think is that in this landscape, co-occurring with tigers, humans and tigers co-occurring, does not necessarily only have to mean conflicts. For a lot of people within this landscape, co-occurring means never seeing a tiger in their lifetime. It means many other interactions that go beyond conflicts. So, without having conducted a formal analysis of this data, or taking away from the tragedy that each of those points represent, I'd like to speculate that human-tiger conflicts within this region are only a subset of the larger set of interactions between humans and tigers, and that co-occurrence may not always imply conflicts. Now, what do these other interactions look like? So while we were conducting our study, people often reported that having tigers on their farmlands often meant that there was a decline in crop depredation because of the landscape of fear that tigers impose on the other herbivorous species there. And this has been empirically demonstrated with tiger populations in Bhutan recently. So moving on to human herbivore interactions, to determine these, we generated a large data set using semi-structured interviews that were conducted in these blue cells. And remember, these are the areas where we had already conducted the farmer surveys, the science surveys, and the camera surveys. So we interviewed 351 farmers across these 46 grid cells, and we generated information on multiple variables, including individual characteristics, their socioeconomic status, attitudes towards conservation, conflict mitigation measures, hunting, etc. And these attitude measurements were essentially meant as a measure of their tolerance of these respondents towards wildlife. We also measured some of the challenges that these communities experience living in these landscapes, and also the conflicts that they were experiencing as the study was progressing. So we measured the type of conflicts, the species that they claimed were responsible, the extent of losses, and the mitigation measures that they employed to deal with these conflicts. What we see is that the median landholding size is about 3 acres in the study area. So most people are practicing a subsistence style of agriculture. That is, they just grow enough to feed themselves. Majority of our respondents were male purely because of the way we conducted our surveys. We were doing these in fields rather than visiting farmers in their homes. Interestingly, in a landscape with multiple large carnivores, some of the greatest challenges that people claim they experienced living here was flooding and crop depredation. And livestock depredation, which we would have expected to be a major challenge considering how much tigers use the matrix, turned out to be not such a big issue at all. In fact, all instances of livestock depredation that we recorded were attributed to the Indian wolf. And this is additionally interesting because prior to this study, we did not know that Indian wolves occurred within this landscape, because most studies within the central Terai landscape had been conducted within protected areas, which are largely areas that are not used by the Indian wolf because of their habitat requirements. When we look at the frequency with which different species were reported as problematic or conflict causing, you see that wild boar tops that list, followed by that large antelope species called the nilgai, macaques, jackals, hog deer, and the tiger figures here down at the bottom. Now I want you to sort of remember the sequence here. So there's wild boar, nilgai, hog deer, and tiger. This trend is also reflected in the probabilities of false positive errors associated with these species. So remember, our modeling exercise allowed us to estimate the probability with which species are reported with falsely, that is, they are reported as present at a site when they are truly absent. So these are the false positive errors associated with these 4 species. So wild boar have almost an 80% probability of being reported incorrectly. That is, at a site where the species is truly absent, there's an 80% probability that a person interviewed at random would report the animal as being present. These probabilities were lower for nilgai and quite a bit lower for species such as hog deer and tigers. Now we may speculate that perhaps what this reflects is people's perceptions of how abundant these species are within the study area. So if you think an animal is more common than it actually is, you're more likely to say it is present at a site and therefore result in a false positive error. So in sort of summarizing that, crop raiding is a significant livelihood challenge in this landscape that is dedicated to tiger conservation, essentially. Consistent with other landscapes, there is a perception that wild boar is the most problematic wildlife in this region, and that we suspect that these conflict reporting may be influenced by perceptions about species and their prevalence within the study area. So then how do we move forward and truly understand how much of these reported conflicts are based on perceptions and how much of this is reality? Because arguably, the measures that we may implement to address perceived conflicts and to address real conflicts are going to be different. Because you want to, where there are real conflicts, you really do want to put in measures that will keep the species away from doing harm to these individuals, whereas these perceived conflicts may reflect something larger, some other sorts of attitudes or tolerance-related ideas. So to address this, we move to a third objective, which is to jointly model species space use and human-wildlife interactions. So I'll sort of walk you through this idea here for a moment. So imagine this landscape with 4 different sites, and you have farmers reporting crop losses by wild boars. So there are these 2 sites here where farmers report experiencing crop losses by wild boars, and there are 2 sites where you don't get such reports. If this is all the information you had, you would infer that these 2 sites are where wild boar occur, and there's nothing you can say about the presence of that species in the other 2 sites, right? But as we saw in the previous case with our data, some of these conflicts could be true, that is, that species actually occurs at this site and there is a conflict episode, whereas in other instances the species is absent and there is a false attribution of conflicts to wild boar. Similarly, at these 2 other sites, this pattern could have arisen because the animal is truly absent at this site and there was no conflict event, or it truly occurred at this site and there wasn't a conflict episode. So to clarify the use state of each of these sites, we can conduct some additional auxiliary surveys that tell us whether or not the animal actually uses these areas. So what is the probability with which wild boar use each of these 4 sites? And we can bring these data sets together using an integrated population model and estimate some parameters of interest, such as psi, which is what is the probability that a site is used by the species. What is the probability that conflict with the species is reported at a site, given that the animal occurs there? The probability that conflict is falsely attributed to a species, given that the animal does not occur there, and the probability of detecting the animal, given that there is the auxiliary survey method applied at that site. So we use this model to sort of model our data on human-wildlife conflicts that we generated using those interview surveys, and integrated it with our data on wild boar detections using camera traps. So it's again data from these blue cells where we had semi-structured interviews, camera trap surveys, farmer surveys, and sign surveys. And we asked, what is the probability that a respondent would experience or report experiencing crop losses on account of wild boar at a site used by the species, and what is the probability of falsely reporting conflicts, assuming the respondent exhibits certain attitudes towards conservation, which is an indicator of their tolerance towards wildlife. So we fit a bunch of models, and this is data, or these are results based on the model with the lowest DIC, and I'll walk you through them. So the probability of a site being used by wild boar was fairly low. It was about 24%. So contrast this with what you would have expected in terms of the sites being used by wild boar if you relied purely on your conflict data. With most people reporting conflicts, you expect the species to be present everywhere, but the fact is to the contrary, that they use these areas with low probability. Where they occur, we detect them with camera traps with a probability of about 30%. And at sites where they occur, respondents are likely to report experiencing conflicts with the species with a probability of about 80%. And at sites where they don't occur, they are equally likely to report experiencing conflicts with a probability of about 65%. And if we look at the attitudes of these respondents who are falsely reporting conflicts, you see that people who had a favorable attitudes towards hunting, that is people who in this case, we interpret this as people who had lower tolerance for wildlife in this area, tended to report conflicts falsely with a higher probability than those who had were in favor of not hunting. So what this essentially represents is a quantitative tool to integrate social and ecological data to tease apart where these interactions between humans and wildlife are perceived and where they are real interactions. And also, more interestingly, disregarding the false positive probabilities, this presents an approach to truly understand what is the probability of conflicts occurring at a site conditional on the species being present at the site. And I would say that this is a true measure of the risk associated with sharing space with a species. And it also helps us understand the ecological or behavioral factors underpinning depredation decisions, which are typically the factors that are associated with conflicts, that is, an herbivore or a carnivore predating upon livestock or crops. And it's equally important to know where these conflicts occur, and also where these conflicts do not occur even though the species is present at the site. So in conclusion, matrix areas provide temporary habitats to tigers and their prey. And so this allows us to think about these populations as being vulnerable to processes that operate beyond protected areas, which is something we do not think about when the focus is sort of explicitly on populations within the park itself. So think about what happens if that large river in the that flows through that study area is dammed in the distant future. Because this river creates habitats for so many of these species, the damming of this river can have consequences that we do not foresee because if we focus all our attention on populations within PAs. The full scale of human-wildlife interactions may be obscured by a narrow focus on conflicts, and therefore there is a need for greater integration of social and ecological data so we can think beyond conflicts and look at all of the different ways in which humans and wildlife interact when they co-occur over a landscape. And I'd like to leave you with some of the species that we additionally detected using the matrix habitats. There's this Saris crane, these endemic and endangered swamp deer. One morning, a rhino walked through the study area. There's also Bengal floricans, an endangered bustard species that use these sugarcane farmlands seasonally. The fishing cats, leopards, etc. So there is a rich assemblage of birds and mammals that consider these matrix habitats home, and I think it would be a tragedy if we as conservation biologists wrote off the value of the matrix because we are so interested in conserving that which is sort of untarnished by human actions. So with that, I'd like to thank some of my funders, the Center for Collaborative Conservation here on campus, the Rufford Foundation, WWF India, my wonderful graduate committee, starting with Barry, Kevin, Tara, Larissa. I could not have done this without you. My field team, who suffered through the intense heat, humidity, rain, floods. The collaborators at WWF, starting with Pranav for making available camera traps. Noon Lab, many of whom are here. It's been an absolute pleasure sharing lab space with you. Friends and colleagues, Paige and Barry, my home away from home. And the FWCB and GDP community, especially Ken, thank you. Ken, thank you. And Joyce, Kim, the WCNR budget office, and finally my parents and my brother, and Danny, there he is. Thank you. Thank you. Oh my God.
Okay, so before we jump into questions, if any of you need to leave for a 1 o'clock class, I know don't worry about that. Some of you have other engagements. So let's just give a couple minutes if anyone needs to depart. And then we have time for questions.
Yeah. It's done. God.